It's now the Interstellar Research Group. And so I'll be presenting actually tomorrow on the Interstellar track because of my professional expertise in carbon-based nanomaterials. I'll be presenting a review of carbon allotropes and its use as photonic sampling materials. So I get to talk all about the new stuff that's come out with graphene and carbon nanotubes, and if you make these sort of lightweight composites, what new types of missions kind of open up that were impossible if you're focusing on the breakthrough starshot laser type propulsions. So we're going to have a pretty robust discussion of that, which I'm really excited about.
Well, for someone who's concerned about math, not that long ago, you've done pretty well here. You got the chemistry and the physics down, clearly. So yeah, sounds like a lot of fun.
Electronics was my worst class in college, but then I go on to invent the tiniest diode. It's like, all right, well, I guess the things that I find really hard are just the ones that are truly motivating.
Yeah, well, I get it. The one programming class I took in college, I just was miserable at it. This woman, just German woman, says, "It's obvious, nothing about Fortran." Well, years later, I ended up with a 31-year career in IT. So, and now I moved into telecom. But yeah, I get it. Sometimes what you study doesn't always work out, but you always find something where you find some passion in.
Yeah, it keeps you involved, and I do IRG stuff as a hobby. Like that's it's all unpaid, it's all volunteer work. But I think we're doing pretty well for ourselves. We're going to have our second European conference, the second European Interstellar Symposium in Venice, Italy, later on this year. Teamed up with the University of Padua for that, which is really exciting. In the IAA. And then we teamed up with Georgia Tech for the 10th Interstellar Symposium that's going to be in Georgia in 2027. So lots of exciting stuff going on. And, we're talking about not just space or habitat or propulsion, but it's, bringing in how does economics evolve over long term? How does language evolve, cultural evolution? These all sorts of things have to play into ultimate mission design, because you can't just slap a bunch of people inside an O'Neill cylinder and say, hey, good luck, and expect them to arrive safely at Alpha Centauri.
I know a few I'd like to put in there. So, I mean, can we keep that option open?
Maybe for the
breathing or not?
Well,
I love talking to interstellar people, because usually I'm the craziest guy in the room, and then I get to your room and they're like, let me tell you crazy. So I love it. I seriously, legit question, are you aiming for warp drives, or you said solar sails, or life ships? If you were to pick one of those three, where would you, how do you think we're going to get to another star?
Yeah, so I do like the idea of world ships or, habitats, things of that nature. My concern for that is the energy budget that has to bridge you the gap, because your ship is going to be radiating energy all of the time in all directions that you're going to be driving through. And so it's like, do you load it up with the mass and energy budget that you're expecting to have to survive a 200, 300, 500 millennium long journey? We don't have the energy storage devices for that. And the amount of uranium or fissile material that you'd have to rely on is extremely large. Now, is there a possible amount of helium-3 or fusionable material in the interstellar medium? We don't know enough about the interstellar medium to actually say yet. And that's where some really interesting rapid missions to the heliopause would actually be quite useful. And Renee Heller out of Germany, he put together a mission concept that got carbon foam sailcraft out to the heliopause in 4 years. And so the work that's going to essentially come from my talk here today is going to sort of develop into new concept development, because he limited his sailcraft to 0.6 AU. I think we can drive it closer to about 0.01 and really push the limitations of the thermal capacity of the carbon foams to get that acceleration. And notionally, a lot of these mission limitations stay further away from the sun because they want to avoid sailcraft ablation. But where I'm headed is I actually want to take a lot more advantage of that.
Okay.
So, you know, I'm just basically presenting the pitch to work together with, you know, other people in that space
Okay.
to come up with some new ideas.
It was interesting. You mentioning interstellar propulsion. You mentioning Dragon Kyber too. Or by chance, this is weird. By chance, do you know a guy named Greg Hodgin, who lives in the Atlanta area?
No.
Okay. Okay. I was just curious. He goes to Dragon Con a lot too, but he presents sometimes. But he's put a group together. It's called the ZC Institute. It stands for Zero Carbon. They're working on alternative energy.
Oh,
And they're doing he's doing something called a quantum hack to kind of get a pseudo fusion,
okay.
out of this machine. But he says the other side of that, I mean, doing that, I convinced him this is what he needs to do to make money.
Mm-hmm.
But the other side of it, tweaked a different way, we might be able to get a workable warp drive out of it.
Yeah.
But I don't let him talk about that, because all funding will dry up tomorrow. But making a small fusion-like reactor that's only like this big and will fit in your car, that's something that maybe it's possible. I don't know.
Yeah, I leave the warp drive stuff to a lot more of the mathematicians in the community. I say, hey, good on you. I'm a materials scientist. If I can't mix it up in a beaker, I'm kind of lost. But there are some.
I just wondered in your circles if you guys had crossed paths. That would have been an interesting meeting of the minds.
Yeah, no, unfortunately we haven't. I mean, John Bradford out of SpaceWorks Enterprises, like we know him. And Brad Cheatham out of Advanced Space.
I know Brad very well.
Yeah. So we've met a couple of times before, and Bart, one of Brad's writers, actually is on our advisory committee. So we've got our fingers in a lot of different areas because essentially these problems are big enough that you have to bring together the communities that are going to point out, hey, if you try this thing, it has knock-on effects over here. So we want to make sure that people are talking to minimize a lot of those knock-on effects. Yeah.
Dennis, did you have a question?
Yeah, so Joe, I don't often get to harass somebody who's got deep carbon nanomaterial type experience whilst they're sitting next to a space elevator guy.
Yeah. So I know that a lot of the issues have come from defect engineering is the big limitation, right? Like, yes, you have tensile strength and the carbon nanomaterials and things of that nature. But where the limitation really comes from is carbon nanotubes sitting next to one another don't interact strongly. The van der Waals forces are actually very weak, so there's a lot of slipping motion that goes on. I am really interested in some of the high pressure work that's going on right now to actually make the synthetic Lonsdale lights, because, and for any of you that aren't familiar with your carbon allotropes, so there are the graphene type sp2 allotropes. It's graphene, carbon nanotubes, buckyballs, all that. And then you've got the sp3 type allotropes, of which diamond is the most famous. But essentially, there is an allotrope called Lonsdaleite that we really only find in nature in meteor impacts. But people are working on creating it synthetically in the lab, and they're creating it synthetically in the lab by taking 2 planes of graphene and then subjecting them to immense pressure so that those 2 platelets cross-link into its own new synthetic diamond-esque type form. And that's going to give you the rigidity and structure that I think has the opportunity to, where you start with tensile strength in one direction that's benefited on the carbon nanotubes, but then if you got them to cross-link in 3 dimensions in a way that nanotube yarns, nanofiber yarns won't be as strong, gives us some hope. But that's, the manufacture of even those initial samples is still like, people are claiming that they've made it, and then the peer review community gets all up in arms. So it's not been in fact made even at the lab scale and confirmed yet.
So only a few stages away from the diamond age.
Yeah. But I think that opens up a lot of the opportunities when you, because thinking from an analogy, right? Thinking from the plastics perspective, you have a hard plastic that exists when you introduce the cross-linking bonds that make sure that the chains also no longer slip past one another. That's how and why thermosets work, right? And so making this new type of allotrope out of the other fundamental carbon allotropes isn't so simple as just giving a little bit of heat. It takes a little bit of new types of chemistry and conditions. But that's where I think the innovation direction lies.
Cool. This thing where you cross-link graphene planes, it wouldn't really be sp2, but it's definitely not sp3 either. So what would you call it?
Oh, it is sp3 because the electrons then become localized when you have the molecular between the planes.
So it'd be like a diamond sheet.
Yeah, and so whereas diamond is an sp3 cubic form, it still maintains an offset chair hexagonal structure.